Now today we're going to combine regions. So when two graphs intersect, the point of intersection can be included or excluded from the region. The following table summarizes the rule. So when you combine the two regions, intersection that is common to one or more inequalities where the regions overlap. If there's two solid lines cross each other, you use a black circle. And then if a dotted line crosses a solid line, it's an open circle. Two broken line, it's an open circle. And then if it's all two solid line result in a black circle, one solid line and a dotted line result in a black circle, and a broken line, two broken lines result in an open circle. We'll go through. Alright, so can you make sure it's dotted so that. Alright, so this is dotted. Alright, okay, that's okay, good. Just fix that. Sorry about that. The printer is not very good. I'm going to continue to record. Okay, let's draw this region. We'll start with a simple example. N means common region, so you draw the graph 2, x, right? And then draw the graph. Frozen. Okay, draw the graph y equal to 2, and then draw the graph x is less than -1. -1, vertical line, and you have to shape the region that's common to both. So you have to shape it above the blue line on the left of the green line, isn't it? So if that's the case, the region you shape will be here. Now using this rule, you have to exclude the point of intersection. Okay, so that point of intersection are excluded because it's intersection of dotted line and a solid line. Okay. Oh, actually, I got it wrong. It's above the line, right? Above, on the left. Over here. Sorry. Oops, I don't know. Anyway, let's do it again. We'll do the same question. And the dotted line. No, it's different. You can't tell the difference in the question. You just said it's the same question. Well, it's similar, but not the same. Can you see the difference? Yeah, it says all. So it means everything. So you shade above the blue line, and you shade on the left of the green line, and then you have to put when the if a dotted line cross the solid line in all, you have to do a dark circle. Right? So your answer will look like this. Yeah. Yeah, because it's either this is true or this is true. So this one, they exclude this point, but this one include the point, so you still include it. Whereas this one, this is, no, you just shade the correct region. And then this one, y is bigger than 2, this is x less than -1, so both has to be true. This one of them has to be true. That's why we have to include this dot. This one we exclude the dot. Okay? Because it's almost saying you either read book or go out, right? So you must have done one of these. But if you say you must read book and go out, and if you didn't go out, means it's wrong. All right, let me try another example. Okay, all right, let me try to answer in a different way. If you Oh, let me think. Oh. Hang on. If you... Okay, think of this way. Okay, listen. If you, listening, if you pass both maths, okay, all right, if you pass both maths and physics, you will win, right? So if you didn't pass maths, you didn't win, right? But what if I change the N to O? If you pass maths or physics, you win. So it doesn't, you only have to pass one of them. You don't have to pass both. Does that make sense? So that's what that means. You have to make both true. So if one of them is true, it's included. Whereas both has to be true. In this case, this is excluded, this is included. So you still have to exclude, right? So that's how it works. All right, hopefully, say again. Yeah, both has to be true. So in this case, the point, so this point is -1, 2, right? This point here. Now, -1, 2, does that make this true? No. -1 is less than -1. Right? Because put the -1 here into x, does that make this a true statement? No. But does that make this statement true? Yes, 2 is bigger than or equal to 2. Correct? Wrong. But you have to be both true. But, say again? I should have. That was good. Okay, so if you understand, that's good. Alright, sorry. Okay. Okay, alright. I thought I have to do something non-mathematical to make you understand.
No, you just got to do good basic mathematics.
Okay. Alright, let's move on to the next one. Alright, this is a circle or radius 2. Okay, good. And draw the line y is greater than 3 to the power x. This is the exponential function. Okay, that's exponential. And it has to be both true inside the circle above the point, so you have to be shaded in between. And then you have to put open circle on both ends, and that's it. Going through 1. Going through 1. 1. Going through 1. This is 1, 3. X, Y. Okay, done. Okay, good. All done. All right, next question. You have to shade in between, so it's below the parabola. What's the equation of the parabola? Y equal to 4 minus x squared. So it's below, so you write y less than x4 minus x squared. Notice it's dotted, so we use less than without the equal. And then what's the other bit? Y has to be equal to or greater than absolute value of x. So you have to write the inequality that describes the region. All right, pretty easy. Once you're done, go to the next page and draw this graph. It wouldn't take you that long. Have a try. Draw this graph. Give you about 5 minutes. Have a try. I'll get you started. First question. I think everyone here should know. It is a horizontal line. 1x. Now try the rest. This is like a summary of all the graphs you should know. Okay, have a try. Give you about 5 minutes. So hopefully you're all finished. So I won't go through the detail. It's all on the next page over here. Okay, have a look. Next page, we've got 2 more pages to go through, then we're done. Let's go through the answers for the second last 2 pages. Okay, so let's go through the summary of all the functions. We need to know how to draw lines like y equal to 2 and x equal to -3. No, we haven't. And then x is -3, right? And then we also have got this line. This line is you have to find x and y intercept. The easiest way to draw is to find the x and y intercept. So x-intercept, that's when y is 0. Put 0 into y, you get 3x equal to 6, x equal to 2. And similarly, to get the y-intercept for x is equal to 0, you should get y equal to -3. And you get a line. Okay? And the next bit is a line that passes through the origin with gradient 2, like this. So you have 3 different types of lines. Horizontal, vertical, lines through the origin, x and y intercept. So there's these 3 types. So remember what to do when you see these, how to draw them. Okay? I am. Yeah. Yeah. So it's all in the video. You can watch it again. Alright. Can't wait. Okay. Cool. Alright. After we do this, we're going to draw the absolute value. That's not, so it's actually quite easy. So just think of that's like a shift to the left, a shift right, 2 units, shift, 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 oops, shift right 2 units. It's a V shape, which you can find the x and y intercept. Leave that to shift, shifting. I should say move right next time. Okay, move right sounds better. Okay, done. And you should know how to draw quadratic expressions like the one below. So make sure you know how to find the y-intercept and the x-intercept, etc. Okay, let's drop this off. So how do you draw this? So you find the y-intercept, y-intercept, that's when x is 0. And when x is 0, you get y equal to -8. That's your y-intercept crossing the y-axis at -8. And then you got the x-intercept. That's when y is 0. That's when you go 0 equal to this. And you factorize the quadratic. Yep. So we get x minus 4, x plus 4, x minus 2 equal to 0. X equal to -4 and 2. 2, -4. And then once you do that, we need to get what we call the axis of symmetry. How do you get axis of symmetry? You average the x-intercept. So if you go x equal to the average, that you will get -1. And at -1, we can substitute -1 back into the formula to get what we call the vertex. And you should get -9. So that's your vertex. I should change this a bit. and then you get the point P, which is your vertex. Oh, sorry, -9. Yeah. Okay, you got this graph crossing at 2. That's your vertex, cross at -8. Yep, that's it. So that's your graph. So how to draw this pen. Okay, good. I'm going to do -9. Oh, -9. Yep, you're right. Okay, all done. Yep. This line axisymmetry or which? Oh, sorry, yeah. So, yeah, thank you. I forgot about it. So, this bit here, let's highlight this. So, don't forget this one where to draw this is much easier to draw. And to draw this, all you have to do is to go shift to the right 3 units, go down 2 units, and you get the graph straight away. So, this one. Okay, so you can tell by shifting, whereas this one you can't draw by shifting. You have to find the x and y intercept and find the vertex. This one gives you the vertex straight away. Okay, just revise this one. So there's 2 different ways, 2 different forms. One is this form, the general form. This is the completed square form. Yeah, okay. All right. Next one is the hyperbola. How do you draw hyperbola? You have to find the vertical asymptote. How do you find vertical asymptote? You make excellent denominator 0, which is half, -half. That's your discontinuity as we learned earlier. -half. What else are they? It's been shifted up 1 unit, which is your horizontal asymptote. And then when I think it's positive, so it's going to look like this. There you go, that way. So it has 2 things, the x-intercept and the y-intercept, which you have to work out. Let's work out the y-intercept. That's when x is 0. So you get y equal to 3 over 1 plus 1, which is 4. It crosses at 4. And similarly, you can find the x-intercept. That's when y is 0. And you get a slightly harder equation to solve. 0 equal to 3 over 2x plus 1. And then you move the 1 over, which is -1 equal to 3. And then you get, yeah, that's reach there. Okay, you flip both equations. You flip 2x plus 1 over 3, the reciprocal. Okay, reciprocal. And then you solve for x, so what will x be? -3 equal to 2x plus 1. X should be -2. So it's comes at -2. So some work involved. Alright. Okay. Yeah, I will. Alright, let's pause this for a while. Continuing. Alright, let's look at this. This one is, what does this do? Unfreeze, sorry. What does this do? Left, 3 units. This is right, 3. This is up, 3. Down, 3. Hopefully you right. Right. Right again. Right. Okay, now what does the negative in front of fx do? No, you go reflect about x-axis. X, that's reflect about y. Okay, cool. Hopefully you know how to do circles, how to find center and the radius, and log everything. Let's go through them. Alright, and then we did regions today, and also domain, we have to go through even and odd, and then limit, all done. Okay, let's look at circles. Put shifting right 1 unit, down 3 units. That's your center. Of radius 2. So you got here, here. So you draw a circle radius 2. Well, that's just the rule. So see, that's -1, you actually move right. This is +3, you move down. It's opposite, yeah. For circle. Yeah. Okay, how about the next one? It's a log graph. To draw log graph, hopefully remember how to draw log x, which looks like this. Right? Dotted line. Oh, I didn't do log for the other one. Okay. And that's a log graph. And what does this do? Shift left 2 units. So if you shift left 2 units, it's going to be, what you're going to do is to draw the asymptote in a new place at -2. And then you're going to draw, it's going to intersect at -1. Go like this. And you can find the one step by putting 0 into log 2. Alright, that's the one step. So now how to use this to shift the graph that you know. Yep, see the original log graph is shift to the left 2 units. So the 1 will shift to the left 2 units to get -1. That's -2. And then cross the y-axis at log 2 if you substitute 0 into x. Okay. Okay, good. I should try the last one, the exponential. Alright, exponential. You have to see what transformation it has. So let's write it differently. Write that as -2 to the power x plus 1. Each of these has a meaning. The +1 is up 1. And what does the negative in front of the function do? You reflect about which axis? The x. Yeah, reflect down. Reflect x-axis. So now why does it reflect x? It's like this one. Like this one, right? Negative fx, right? The negative is in front of the function. Reflect x. Alright, so think about what it will look like. You reflect the x and then shift up 2 units. So it's going to be here. Right? And then it's going to go like this, passing through the origin. Right? 0. And can indicate a point on there when x is 1, it's at -1. Alright. Okay, think about this. Alright, good. Continuing. Okay, good. Let's go through the region bit. Regions are pretty easy. Y less than 1, X more than 2. So you're going to shade on the right with an open circle here. Like that, yeah. That's cross that too. Okay, so shade regions. And this is a circle. 2. And then shade inside. Put a dotted circle. Okay, good. Alright. Okay, good. So, all done. There's the main range. Have a try, see if you remember these. Yep. That's a good question. I should have said it's and. Yeah. I think the textbook, they always do and. Yeah, okay. Yep. Alright. Hopefully remember how to do domain. How do you find the domain inside square root? What do you do? When the inside the square root has to be positive. So the domain is this. Hopefully you still remember. What if for the next one, what would you do? The denominator has to be not 0. That's the discontinuity. X can't be half. Right? So that means all real X. So you say all real X except X equal to half. Right? That's your domain. Yeah. No? Okay. Try the other ones. Have a think. What if you have a square root in the denominator? What difference does it make? You still make it positive, but you don't make it equal to 0. You write bigger than 0. See the difference between these two? They look similar, but they are different. Because one is bigger than equal to, one is just bigger than without the equal to. So that means X has to be more than half. Now how about the last one? What's the domain? Is there any restriction? Does it have square root? Does it have X in the denominator? Nothing. So you say all root X. And what type of graph it is? It is a parabola, right? So it's all real X. When a parabola, the domain is all real X. Right, so that gives a good summary of the whole topic. There's a lot of graphs you have to learn. There's words you have to learn, domain and range and everything, and even the odd function limits. So, yeah, okay. All right, and also we need to know what an even and odd function is. What is an even function? If f negative x equal fx. You're going to expect it to know this for the exam. And the odd function if f of negative x equal to negative fx. And there's some example you could try below. Prove it is even. So you do g negative x equal to 5 negative x power 4 minus 3 negative x squared. What would that be? That would just be 5x power 4 positive minus 3 positive x squared, which is g of x. We say, therefore, g of x is even. Right? Okay, good. Try to prove that hx is odd. Okay, using the same technique, similar technique. Right, have a try. Alright, let's do the odd one. Odd. H negative x equal to 5 negative x power 3. But when it's negative, inside a odd power, you get negative plus 3 power 3x. And then you factorize the negative out. And what happens if you factorize the negative out? You will find that the sum here is hx. So negative hx. And when it's a negative, which is fixed the definition above, you say therefore hx is odd. Right? Alright, so you got all this. And then we'll also do limits too. You may write it down. I will leave it on the board and then we'll just stop the video. Okay, hopefully I'm still recording. I am, yep, sometimes I forget. Okay, just write limit. X approaches 2, we'll just do that in the quiz today, so no need to worry if you didn't see my explanation. Make sure you do that. Cancel equals to lim. X approaches 2, x plus 2 equal to 2 plus 2 is 4 is the answer. Okay, I'll leave it on. That is a very long topic and very important topic. So make sure you take the time to review my booklet and review my video. So,